Hey guys, welcome back. Last when we left off, we were working on this assignment, strategies for solving equations with fractions. So we got about this far, about through the first page in class, and also in the last video. If you check that out for Thursday, then you'll see me working through at least this part. Okay, so when we left off, we had set up problem number 6 and problem number 7. We had determined that 80 would be the lowest common denominator that we need if we were going to get common denominators, and then we multiplied both sides by 80, and then we distributed. Over here in number 7, we determined that the lowest common denominator was going to be 24, because 12, 2, and 8 all go into 24. And so we started setting this up by multiplying both sides by 24. Now, if you haven't already, what I want you to do is I want you to work through the rest of this problem, do your best, see what you can come up with. And then I'm going to show you the solution. So if you haven't finished these yet, go ahead and pause the video now and finish working them. Okay, if you're coming back from pause, then you should have something similar to this. Okay, so we multiplied, number 6, we multiplied both sides by 80. We distributed. This is where the canceling happens. Let's see if I can zoom in a little bit more for you there so you can see my writing. So here, when we cancel, we're left over with a 10. Here, when we cancel, we're left over with a 16. Here, when we cancel the 80s, we really are just left over with a 1, 113 times 1. So we got the 10 times 5. We got the 16 times 9v from the middle. We got the 113 over here. And then just kind of simplifying, this is what our two-step equation is. So now from here, I'm just going to solve that two-step equation. I end up with a fraction, which is okay. That sometimes is the case. And then just make sure you reduce that fraction all the way. And then if you need to pause here and kind of follow that along again, or kind of at your own pace, you can go ahead and do that. Okay, number 7, I'm going to go slightly faster because we've already done 2 of them now. We multiplied the lowest common denominator by 24. Excuse me. We multiplied both sides of the equation by the lowest common denominator, which was 24. When we cancel, we get a 2, a 12, and a 3 left over. So 2 times 49 was 48, 12 times p was 12p, 3 times 37 was 111. Again, now it's just a two-step equation, which you should be familiar with. We're going to subtract 111 from both sides, and then divide both sides by 12 to get our solution. Okay? All right. So remember that strategy is called clearing the fraction. And instead of getting common denominators, you actually just get rid of the denominators. You cancel them all at the same time. And that's a different strategy. Okay? So let's keep going. Okay. So explain why we can't use the clear the fraction strategy for problem number 2. Well, let's look at problem number 2. Okay? So problem number 2 is this guy. Okay? If we compare problem number 2 and problem number 3, what do you notice? Number 3 is an equation. Number 2 is not an equation. It's an expression. So the clear the fraction strategy uses the multiplication property of equality. And we can't use the multiplication property of equality if I don't have two equal signs. Or sorry, excuse me, if I don't have an equal sign with two sides. Excuse me. The multiplication property of equality is what lets me multiply on both sides of an equation. But if I don't have an equation, I don't have two sides, and I can't use that property. Okay? So the clear the fraction does not work in this situation. We have to use a different property. We actually have to use the identity property. Okay? Clearing the fraction, that strategy, only works in an equation scenario. Okay? So put that in your own words here. I'll give you, you can go ahead and pause and you can kind of write that in your own words. Okay, so you should kind of have this in your own words, but the idea here is that clear the fraction, I'm going to use CTF as a abbreviation, uses the multiplication property of equality. We can only apply that property of equality on equations, something with an equal sign in it. So this property doesn't work. With expressions. Okay, that's a really big idea here, because when I show people the clear the fraction strategy, they're like, oh, this is awesome, like I don't have to deal with fractions anymore. It kind of depends, right? Like if you have an equation, that's true. If you don't have an equation, you can't use that strategy. And so I see students try to apply that strategy incorrectly in the wrong context when they don't have an equation. So I just want to make sure that we're clear on that. Okay, now the next few problems here is actually just kind of like a stepping stone, okay? We're practicing a skill here that we're actually going to use in the final problems of this assignment. So it may not totally make sense why we're doing this. We're just practicing a skill. We're going to practice distribution and simplifying with fractions and things like that. But this is actually going to come in really, really handy on the last page of this in-class worksheet. Okay, so what we're going to do is distribute, and then we're going to use the multiplicative inverse to simplify the expression. Okay, multiplicative inverse is when you basically cancel, like when you have 5 over 5 and you're like, oh, that's just 1, right? That's multiplicative inverse. It says, like when in symbols, it's a over a equals 1, or sometimes written a times 1 over a equals 1. Okay, so when you're multiplying something and that same thing is in the denominator, you can kind of cross cancel. We talked about that in class yesterday as well. So let's take a look, okay? So we got 15 here, and we're going to distribute. So kind of similar to what we've been doing on the previous page, right? So we have 15 times x over 5. Okay, now what I'm going to do here is I'm going to put the minus sign next. So we got these two terms that are separated by the subtraction sign. So I'm going to put the subtraction sign next. Then I'm going to bring in the 15 and multiply it by 7/3. Okay. We want to be able to kind of keep these two pieces separate with this subtraction. If I'm distributing to two pieces, I'm going to end up with two pieces, and there should be a subtraction in the middle. Okay. Now, kind of going back to what we were doing before, if there's a common factor that we can cancel, we're going to go ahead and do that. So since 5 goes into 15, we're going to cancel out that 5 that goes into 15, and we end up with 3. Okay, really what we mean is there's a 5 up here that cancels with the 5 down here, and what's left over when we do that is a 3. Okay, over here we got a similar idea. We got a 3 and a 15. So 3 goes into 3, also goes into 15. So since that's a common factor of 3 and 15, we're actually going to cancel out this 3. We're going to cancel out the 3 that is a factor of 15, and what's left over is going to be 5. So we have 3 times x is 3x, okay? And then we have basically negative 5 times 7, or you're going to subtract whatever 5 times 7 is, however you want to think about it. In this case, that's a 35, okay? So we've kind of already done that skill, but what's going to happen down here is it's going to get a little bit more complicated, all right? Notice that there's actually 2 pieces in the numerator here and 2 pieces here. And so what we got is these numerators that have 2 pieces in them. And we call those binomial numerators, which means 2-term numerators or two-piece numerators. Okay, let's go to do number 10, and then we'll continue and we'll tackle those in a second. Okay, so the same idea here. We're going to distribute. Okay, don't cancel before you distribute. That's a common mistake that people make, is to oh, 12 goes into 24 and cancel. You can't do that yet because 24 still has to multiply this guy. Okay, so I'm going to put 24 here and then the 5 over 14. So once again, I kept the subtraction in the middle. If you do 24 times this negative number, if you want to think of it as a negative number, you're going to end up with a negative number. So it's still legal, just kind of helps me keep track of the 2 big pieces that are separated. All right, so 12 goes into 24 2 times. Now this time 14 can't go into 24, so we got to just find the common factor. So in this case, the common factor would be 2, and 2 goes into both, which actually what that means when we say 2 goes into both is that 2 cancels. Because really what we have is we have like a 2 up here and a 2 down here that are gonna cross cancel. Okay, So the 2 down here cancels with the 2 up here. We're left up with a 7, since 2 goes into 14 7 times. And we're left with a 12 here, since 2 times 12 is 24. Okay, so what we got left is we got 2 times 7x, okay, that's 14x, minus 12 times 5, which is 60, over 7. Okay, so we still have a fraction here. That's okay. Not everything canceled. We're going to talk about that a little bit later. Why didn't everything cancel? Okay, so we're just simplifying. Okay, we're practicing this skill that we are going to need as part of the clear the fraction strategy. Okay, the reason why we're taking a break to practice just that piece is because sometimes that piece is more complicated. So let's take a look at a few of these. All right, the same thing's going to happen here in number 11. Okay, we're going to distribute the 6, kind of like this. Okay, and then we're going to have 6 times x over 6. Okay, so we already know that the parentheses act as a grouping symbol, right? It kind of keeps everything together. The other grouping symbol that you see here is actually these fraction bars. The fraction bar acts as its own grouping symbol, kind of like an implied grouping, and so we need to keep that in mind. Okay. All right, so here's what we can do. Right now we're going to look for the common factors, right? Is there a common factor here? The answer is yes, it's 2, and so that common factor is actually going to cancel out. The 2 down here is going to cancel out with the 2 that's part of 6. It's the 2 that's a factor of 6. And what's left over is the 3, because 3 times 2 is going to be 6. So 2 goes into 2 once, we cancel it out, we don't need to write a 1. 2 goes into 6 3 times. Okay, here we got a 6 and a 6, those just cancel. When there's nothing left, really we know that that's a 1. So we would say this is 1 times x. We don't usually write that 1 though. All right, so now what we have here is we have 3 times this thing. Okay, now again, this fraction bar acts as another grouping symbol. So when we rewrite it, even though we don't have the fraction anymore, we still have this grouping symbol. And so we actually have to distribute one more time. So these guys, it's not just 3 times just this guy, it's 3 times both of these terms. So we got 3 times 3x, which is 9x. We got 3 times negative 1, which is negative 3. And then we have the plus x. Okay. As our last step here, we need to combine the like terms, which are these guys. Now, really when we do that, we don't always write this step, but in our minds, what we're really thinking is that it doesn't matter the order that we write these terms in. As long as that negative stays stuck in front of the 3, we're good. So we kind of mentally rearrange it, put the like terms next to each other, combine them. Remember, this is a 1x, not a 0x, so 9 plus 1, invisible 1, is going to give us 10. And then we have the 3. Since the 3 is not a like term here, we're just going to kind of leave this. Okay, so this is just a simplified expression. All right. So let's do it again. Actually, what you should do right now is you should try number 12. Okay, so try it on your own, and go as far as you can. And if you get stuck, we'll talk about it in a minute. So go ahead and pause and try number 12. Okay, coming back from pause, we're going to distribute the 12. That's our first step. So 12 multiplies the first fraction. We got a plus in the middle. 12 multiplies the second fraction. Okay. Then we're going to look for common factors that we can cancel. So 4 and 12 have a common factor of 4. In other words, 4 goes into 4, and it goes in 1 time, and 4 goes into 12 3 times. Okay, over here we have 12 and 10. The common factor there is 2. 2 goes into 10 5 times, and 2 goes into 12 6 times. Okay. All right. Now we can go one step further because now we have like a 5 over 5. And we actually could have simplified this to begin with if we wanted to. But this 5 over 5 is just going to become a 1. So this is actually 6 times 1. Again, we don't usually write that 1, but we know it's a 1 when we cancel that way. So going back to the beginning, we have 3 times m plus 1. Remember, the fraction bar is like an implied grouping symbol. Okay. Then we have the plus 6 times 1, which, is just 6. Okay, our last step here, second to last step is we're going to distribute this 3 now. Okay, so we got 3m plus 3, and then we have the plus 6. Okay, now we can combine our like terms. Okay, now these are already next to each other, which is kind of nice. So we don't have to think about rearranging it really. 3m is just 3m, and then 3 plus 6 is going to be 9. Okay, so that's our simplified version. If you didn't get that, then maybe go back and troubleshoot, think about where you went wrong, make sure you understand why, so that as we move on that you understand. Okay, these guys are a little bit trickier because now we have two fractions that have those two pieces up front. And again, we call that a binomial numerator. All right, so let's take a look at number 13 here. So the first step is the same. We're going to distribute. Okay, now we're going to cancel common factors. So we're going to cancel the 3, common factor of 3. 3 goes into 3 once, so we cross it out. 3 goes into 12 4 times, so we leave a 4 there. Okay, over here, 4 goes into 4 once, and it goes into 12 3 times. So the common factor was 4, and we end up with a 3 left over. Okay, so I'm going to rewrite this as 4 times 2x plus 1, because remember this is a grouping symbol. Okay, and then we have negative 3 times 6x minus 1. Okay, now when we think about this thing right here, sometimes we think of it as a negative, and sometimes we think of it as a subtraction. Sometimes we, say, well, it's attached to this 3, and sometimes we say, well, it's just separating these two terms. Okay, we got to be able to kind of go back and forth in between those ideas of what that sign means, because in the next step we're going to distribute, and we actually need to distribute that negative. Okay, so if there's a subtraction in the middle of your fractions here, okay, be very careful that you do this correctly. Okay, so I'm going to show you where most students make a mistake. Okay, so 4 times 2x is 8x, 4 times 1 is 4. Okay, negative 3 times 6x is negative 18x. Notice I multiplied by negative 3, right? The other thing we got to do is we got to multiply it by the negative 1. So when you distribute this negative 3, make sure you're distributing the negative with it. Okay, negative 3 times negative 1 is positive 3. So be very careful there with that negative. Don't lose track of it. It looks like, we're just subtracting a whole chunk, but when we get it into this form, we are subtracting, or it's like a negative 3. We're actually going to subtract both of these pieces. When you subtract negative 3 times 6x, it's negative 18x. When you subtract negative 3 times negative 1, it's actually a plus 3. Right? So like subtracting a negative is actually adding, or multiplying a negative by a negative is actually going to give you a positive there. Okay, so if we wanted to, we could use the commutative property of addition to rearrange all these terms so that the like terms were next to each other. We kind of do that mentally. We don't always write out that step, and that's okay. So what I like to do sometimes is I like to just kind of use symbols to group my common terms or my like terms. So I put a squiggly under everything that had a x, and I'm going to circle everything that doesn't have an x. So these are the like terms, and these are like to each other, and these are like to each other. So these I'm going to combine. Now again, if you want to rearrange them and put the x's next to each other, if that makes more sense to you, you can do that. If you want to put the regular numbers next to each other in the back, you can do that. Usually at this level of algebra, we can do that mentally. So an 8 and a negative 18 together is going to be a negative 10x, because they both have x's, and then a positive 4 and a positive 3 is going to give us a positive 7. Okay, so that's how that one works. All right, so you try number 14, okay? Try it on your own, distribute the 18, see if you can get the right answer, okay? I want you to try it first so we can see if there's any errors in your thinking. If there are, we can come back and troubleshoot them. So go ahead and do 14 now by yourself. Okay, coming back from the pause, we're going to do this kind of quick since we already did some examples here. We're going to distribute the 18, okay? I'm going to put the negative here, and then the 18 there. Okay, I'm going to cancel my common factors. So 9 goes into 18 twice, 2 goes to 18 9 times. That means I have a 2 times 4x plus 3, and then like a negative 9 times 2x plus 1. Okay, so be careful with the negative when we distribute here. We'll start with the 2 though. 2 times 4x is 8x, 2 times 3 is 6. Okay, negative 9 times 2x is negative 18x, actually looking kind of similar over here. And negative 9 times 1 is negative 9. Okay, so we got an 8x, we got a 6, we got a negative 18x, and we got a negative 9. So be careful that you got both of these negatives as you distributed. Okay, these combine to a negative 10x again. These combine to a negative 3. Okay, so if you didn't get that, see if you can figure out where you went wrong, and then make a mental note of that so you don't make that mistake again. All right. Okay, this is kind of a reasoning question. In problems 9 and 11, these two guys, these two guys, the fractions went away. We didn't end up with any fractions. Okay. That wasn't the case in problems 10 and 12. So in 10 and 12, actually, did we? Oh yeah, these actually did simplify. That did happen. So let's just say that wasn't the case with problem 10. Okay, wasn't the case with problem 10. Why is that the case? Okay, we got to kind of think ahead here. Well, if you look at the 15 will cancel the 5 and the 3 because 5 and 3 are both factors of 15. Right? There's a 5 inside the 15 and there's a 3 inside there. They're both factors. So we know that those are both going to cancel. Okay? Same thing happens over here in 11. 6 and 2 are both factors of 6. Or in other words, 6 is like it's the lowest common multiple of both 2 and 6. That's like our lowest common denominator. So we know these are going to cancel because they both go into 6. In 10 though, 14 does not go into 24. Right? 12 does, and so that part canceled, but the 14 doesn't go into 24, and so we ended up with a fraction. Okay? The reason why that's important is when we're doing the clear the fraction strategy, which is the whole point of this exercise, is we have to multiply by something that's going to cancel everything. If we don't multiply by the right number on both sides of our equation later, it's not going to cancel all the denominators, and so we're going to get kind of stuck. Okay, so that's something to keep in mind. So in 9 and 11, the fractions went away. Why wasn't that the case in 10? And the reason why is that 24 is not a common multiple of 12 and 14. Or in other words, 12 and 14 are not both factors of 24. We could probably have just written because 14 is not a factor of 24. In other words, this 24 is never going to cancel out the 15. We're always going to have something left over. Okay, that's just something to keep in mind as we try to choose the number that's going to cancel everything in our process. So just really quick, going back to the previous page. Okay. Why did we choose 80 here in number 6? Why do we have to multiply both sides by 80? What's special about 80? Well, 80 is the number that's going to cancel all of these things. Why do we multiply by 24? Because 24 is the number that's going to cancel all those things. We don't want to multiply by a number that's not going to cancel all our denominators. Otherwise, we're kind of missing the point of the clear the fraction strategy, right? We have to pick a number that all of those go into. So going back over here to 10, if we were doing clear the fraction, we shouldn't have picked 24, right? We should have picked a different number that would have cleared both of those. Okay, so this isn't an equation solving process right here. This is just an expression. This is just practice, but that's just kind of thinking ahead. Okay, so we're going to stop the video there for now. We still got one more page to go. Okay, so I'm going to stop the video, and then I'm going to come back in the next video, and we're going to talk about these two problems. Okay, so it's another clear the fraction idea. The difference here between these ones and the ones we looked at before, 5, 6, 7, and 8, is that these have the two pieces in the top. Okay, so we're going to pick our lowest common denominator, we're going to multiply, we're going to do all our distributing. Okay, so these are a more complex version of what we just seen. So tune into the next video to check that out. Thanks for watching.